the front view of a 90 mm long line which is inclined at 45 degrees to the XY line, measures 65 mm. The NDA is 15 mm above HP, above XY line, and is in VP. Draw the projections of the line and find its inclination with HP and VP. So he says the NDA is in above XY line. So above XY line means it is above horizontal plane. So when you look from the front view, you can see the distance above HP, which is 15 mm, that is shown here. So when you look from the front view, the image will go to be seen in the vertical plane. So we're going to consider this point as A dash. And it is in VP. So when you look from the top view, it is on vertical plane. So obviously that image will go to be seen on the horizontal plane. So we mark this point as small a. And the front view of a 90 mm long line is inclined at 45 degrees to the XY line. So measure 65 mm. So he has given the true length of the line and its inclination with respect to HP, that is XY line. So from here, when you look from the front view, we can see the distance. When you look from the front view, we can see the length of the line, which is 90 mm, which is inclined at 45 degrees to the XY line. To draw a line, so this length of the line will going to be 90 mm. So now we are going to get the true length and its inclination. So once you get the true length, so you have the front view with a locus line. So we're going to write the dashed out line here on the vertical plane. So this will going to be the locus of B in the front view. So since it is the true length, so you're going to have capital A and capital B1, and this is B1 dash. Then the front view measures 65 mm. So with A dash as center, take the radius of 65 and cut an arc on the locus of B, which is going to be B dash. So join A dash B dash with a dark line. So this will going to be the front view. But nothing is given in the top view now. NDA is only on VP, that we know, but the rest of the things we don't know. So now we can find out the true length in the horizontal plane. How? Because we know that the true length is given, which is 90 mm long. So in the front, you know the front view. Once you know the front view with A dash as center, once you know the front view, and also we know the true length in the front view. So since we know the front view, so the distance between the end projectors in the front view and top view both will going to lie on the same line. So we will going to draw a vertical projector from B dash to the XY line, and again you draw a vertical projector from XY line to the top view. And we don't have any locus here, but we know the front view true length. We know the front view true length. That means it is the line which is parallel to VP. Since it is line parallel to VP, so you are getting the true length in VP. So since this line is in true length, so obviously the top view of that line will be parallel to VP. So NDA is in VP, so B1 should also be on VP. So from B1 dash you draw a vertical projector such that it will going to meet the XY line, because NDA is in VP, so B1 is also on VP. So AB1 is the line which is on VP. So that is both the points are on VP. So obviously the line is parallel to VP. Since it is parallel to VP, so we are getting the image on the horizontal plane. But we know this is the top view, which is AB1. But the top view of the point B1 will not lie on VP, but instead the line will be on the end projector, because we have the front view. So on the same line, the top view of the point B1 will going to come and touch us. So with A as center, take the radius of AB1 and draw an arc such that it will go to cut the end projector, which is drawn from the front view to the top view at this point, which will going to become B. Then join A to B with a dark line. So this will going to become the top view. So when you project this, from B you draw a vertical line, and from B dash you draw a horizontal line. Both will going to meet at this point. So this will going to become capital B. So this is the line which will be in space. So this is capital AB. So now, so since we are rotating like this, so that means when B1 is there, so when with capital A as center, take the radius of A dash B1 dash, that B1 is rotated, capital B1 is rotated such that B1 point will going to lie on the end projector of drawn from the top view, from the front view to the top view. so that this end point of this B, that is this B1 dash, this vertical line will going to come and touches on this end projector line here. So you are going to get this line here. So then you are going to get the, so once you get the top view here, so now we got the locus of B in the top view. So now we need to find out the true length in the horizontal plane. So with A as center, take the radius of AB and draw an arc, rotate it B such that A is above HP by 15 mm and that B2 also above HP by 15 mm. So the line is parallel to HP. So when you look from the front view, what happens is this whatever we have been rotating in space, that will be path will be taken on the vertical plane such that with A dash as center, the B dash as A dash B dash as the radius, we draw an arc such that A dash B2 dash will going to be parallel to HP. So once you get the parallel to HP, so we are getting the true length in HP. So when you are looking from the front view, so this AB2 which is in space, when it is projected onto the vertical plane, you will going to get A dash B2 dash. And when you look from the top view, the image will going to form on the locus of B here, so that you will going to get the true length in HP. So this is the, when you look from the top view, this is the line which will going to be projected here, and this is the line which is going to be projected here. So when you look from the front view, this is the line what we have here, so that has been projected from here to the XY line. So when you look from the top view, we can see the distance which has been projected onto this. So similarly you have been projecting this to the locus of B in the top view. So then you will going to get the line AB2, which is the line which is parallel to HP. So this will going to be the true length in HP. The inclination made by this with respect to VP is called phi. The apparent inclination made with respect to the top view, which is with respect to VP, is beta. Now, so this is how we can analyze this problem in the 3 dimension. Now we will going to apply that in how to write it in sketchbook. First we will going to draw the XY line and mark VP and HP. So he says NDI is above HP by 15 mm. So from XY line we measure 15 mm. Above HP means it is on VP. So obviously VP is above XY line and draw a horizontal projector. And then NDA is in VP. So from consider any point and draw a vertical projector so that A dash is above HP by 15 mm and A is on VP. So the image is going to be on HP. So you are going to get this point. Now he has given the true length in VP. So from A dash you draw a line which is inclined at 45 degrees by using the protractor to measure an angle of 45 degree and then draw an inclined line. By using the compass with measure a distance of 90 mm with A dash as center, cut an arc on that 45 degree line. So you are going to get this point B1 dash. Then draw the dash dot line in the front view. So this will going to be the locus of B in the front view. Now we know the front view as given at 65 mm with A dash as center, take a radius of 65 and cut an arc on the end projector. Locus of B, so that you are going to get this point B dash. The length of the front view will going to be 65 mm, which has been as shown. You mark that point as B dash and join A dash B dash with a dark line, which will going to be the front view. Now we know that the distance between the end projectors in the front view and as well as in the top view will going to remain the same. So from B dash you draw a vertical projector to the top view, but we don't have the locus of B in the top view. So it will extend further down. But we know the true length in the front view. Since we know the true length in the front view, its corresponding top view will be parallel to VP. Because it is the true length in the front view is a true length in VP. So obviously its corresponding top view will be parallel to VP. So NDA is in VP, therefore B1 should also be on VP. So with B1 dash, from B1 dash draw a vertical projector so that it will go to come and touches the locus of A in the top view. So that means A is on VP, so B1 will also be in VP. So that is what we have got the line here, AB1, and it is projected from B1 dash. But we know that the top view of the point B1 will not be on VP. It is instead of instead of in front of VP, such that this B1 will going to lie on the end projector which has been drawn from the B dash, so that it will going to meet at this point. So with A as center, take the radius of AB1 and then draw a arc by using the compass, such that the B1 will going to touches the end projector which is drawn from B dash from the front view. So you mark this point as small b and then join A to B with a dark line. So now we got the locus of B in the top view. So now we have the locus of B in the front view and also locus of B in the top view. Now we need to find out only the true length in the HP. So since we want to find out the true length in HP, obviously that line has to be parallel to HP. So the front view is the line which is inclined to HP. You make that line parallel to HP. With A dash as center, take the radius of A dash B dash. By using the compass, draw an arc such that B2 dash and A dash both will be above HP by 15 mm. So that is what we have done here. From A to B, rotate it such that AB2 is the line which is above HP by 15 mm. So here A dash and B2 dash is above HP by 15 mm. So when you look from the front view, this is projected into B2 dash and this is projected into A dash. So A dash B2 dash is the line which is parallel to XY in the front view. So you can see A dash B2 dash is the line which is parallel to XY line in the front view. So then we are projecting this to the down and then we are projecting into the locus of B in the top view, so that you are going to get this true length here. So draw a vertical projector from this, you are going to get draw a vertical projector from B2 dash such that it will going to cut the locus of B in the top view, which is B2. Then join A and B2 with a little bit thicker than the projector line. So this will going to be the true length line. The inclination made by this with respect to VP is phi. And the inclination made with respect to apparent inclination made with respect to front view, which is alpha, and apparent inclination made with respect to VP will going to become beta. So by using the protractor, you measure an angle in the front view, apparent inclination with respect to HP, which is alpha, which will be equal to 78.26 degrees when you are doing it in computer. When you are doing it in manual, it will be 78 degree. Similarly, by using the protractor, you measure an angle apparent inclination with respect to VP, which is beta, which is 78 degree, both in computer and as well as in manual. And true inclination with respect to VP, which is phi, which will be equal to 43.76 when you are doing it in computer. When you are doing it in manual, it will be 44 degrees. So this is how you will be able to solve this problem in sketchbook. Now we will going to take up this step by step. So first we are going to take up how the true length has been found out in the, how we will be able to consider the top view and then got the locus, and then how to find out the true length in HP. So that is the condition. So in the first step, first we know, first we have taken XY line, we have measured this above HP, A is above HP by 15 mm, and on VP, so we are going to get the top view here, A. So we know that the true inclination with respect to HP and also the true length has been given. So you draw this 90 mm line with 45 degree. So you are going to get B1 dash. So this is the true length. So then draw a dash dot line which will going to be the end project locus of B in the front view with a dash dot line. Then we know the front view, the distance is given 65 with A dash as center, cut an arc on that locus of B, so that you will going to get B dash. Since we know the front view, so its corresponding top view will also lie on the same end projector. So you draw your end projector to the top view. But we know the true length in vertical plane, so obviously that line will be parallel to VP vertical plane. So NDA is in VP, so B1 is also on VP. So that is what we have done here. So we have this line, when it is projected, you are going to get AB1, which is in front of, which will be on VP. So both the points are on VP, so obviously that line is parallel to VP. So then with but B1 will not be on VP, but instead the B1 will be on this end projector, which is drawn from the front view, which is B dash. With A as center, take a radius of AB1 and draw an arc such that it will going to cut the end projector at this point B. So then Mark this point as B. Join A and B with a dark line. So you're going to get the top view. The inclination made by this with respect to VP is beta. So we find out beta. And also we found we need to find out the alpha. The alpha inclination is known. So alpha inclination will be 78.26 when you are doing it in computer. When you are doing it in manual, it is 78 degree. So this is how we will be able to get the first step. So that is what we have done here. So with A as center, take the radius of AB1. When you draw an arc such that this B1 will going to be on the end projector point of this, so that it will cut here. So this is the line which will going to be cutting that on this line end projector. So you're going to get this point B. So when it is projected, this point will going to be in space. So since you are rotating from vertical plane to in front of VB by some distance, so naturally that will be on the locus of B here. So that is the end projector. Now we will go to take up the second step. When you are taking the second step here, so we know the front view. Now we want to find out the true length in HP. Since we can how to find out the true length in HP, so make the line which is inclined to HP. The line which is inclined to HP is A dash B dash. So with A dash as center, A dash B dash as the radius, we have drawn an arc such that both A dash and B2 dash will be above HP by 15 mm, and draw a vertical projector from B2 dash to the locus of B in the top view, so that you are going to get small AB2, which is the line which is going to be the true length line. Denote this by capital A and capital B. So the inclination made by this with respect to VP is phi. So mark this phi and identify. Measure the angle. So this is what we have done in the when with A as center, take the radius of AB, then draw an arc such that B will going to touches B2, so that both capital AB2, which is above HP by 15 mm, so that this will be the line parallel to VP, parallel to HP. So since it is parallel to HP, so when you look from the top view, you will be able to get this particular line, which is going to be the true length line, and inclination made by that with respect to VP is phi. So when it is projected in the front view, so this is how it is going to be rotated and make it parallel. Then this is the projection what we have done. So we are going to project this. So we are going to get this line directly. So this is how the problem can be analyzed in stepwise also.